Hi, everybody. I'm Vince Mickens, and welcome to the latest edition of All Things Aviation and Aerospace. As all of my loyal viewers, listeners, and followers know, I like to include every option and possibility when it comes to aviation and aerospace careers. And as a result, I've covered a wide variety of career options, including, most recently, the availability of numerous aviation scholarships, robust aviation and aerospace internship programs, and aviation and aerospace summer camps. But since I hadn't done anything in a while with NASA, I thought that it would be a great time to reach out to them and seek out something different that most of us might not be familiar with. Well, they obliged me. So, thanks to the director of NASA's Johnson Space Center, Vanessa Weich, I was introduced to a significant aspect of NASA space exploration, space architecture. Yes, initially I thought, space what? But as soon as I started to learn what space architecture actually is, a fairly recent label in space exploration terms, I might add, and that it has been around since our beginnings in space exploration, it made a lot of sense. So I did a deep dive, did some research, and was really blown away, although not necessarily surprised about all that is involved with space flight and space exploration architecture. My biggest takeaways are human-centered design factors with space habitability, the most important aspect of designing with humans in mind. Things like life support, protection from the elements of space, and comfort. I mean, after all, we're talking about somewhat confining living and working quarters for extended periods of time. So I have three great guests, two of whom are very experienced in space architecture, and one who I affectionately refer to as a newbie, but is an inspiring representation of our future in space exploration. This was originally going to be one show. However, because of all three having very compelling stories to tell and even more captivating insight on this unique aspect of NASA, I decided to break it up into three separate episodes. Episode part one features Dr. Robert Howard, the Habitability Domain Lead at NASA Habitability Factors Branch, as well as the co-lead of the Center for Design and Space Architecture at the NASA Johnson Space Center. Dr. Howard holds bachelor degrees from Morehouse College and Georgia Tech. He has a Master of Science degree from North Carolina A&T State University, and he got his doctorate from the University of Tennessee Space Institute. For part two, also from NASA, and she's my newbie, is Clare Luckey. Clare, who recently started at NASA in Mission Analysis and Integrated Assessments, or MAIA, as NASA affectionately calls it. She is also part of NASA's Mars Architectural Team, or MAT. Then stepping outside of NASA, part three will be my interview with Dr. Olga Banova, the director of the world's only Master of Science Space Architecture program, part of the Sasakawa International Center for Space Architecture at the University of Houston. Yes, you heard me correctly. It is the only space architecture graduate program on planet Earth. Dr. Banova is also a research professor at the University of Houston's Cullen College of Engineering. So let's get things started. Here is my interview with Dr. Robert Howard. Dr. Howard, welcome to the show.
Hello, Vince. Thank you. It's good to be here.
It's great to have you and looking forward very much to this conversation. I have learned a lot pre-show about it, but now we get to hear it directly from you, and our audience gets to learn about something that is, I call it unique. It's been around for a while. You've obviously been doing it for a while, and from the research I see, it's been a thing going back decades, but it is still something that we don't hear about. We hear about the obvious. We hear about the astronauts and their travels in space to the space station and the plans to go to the moon and the plans to go to Mars and things like that. But there's a lot more to it than just, putting on a spacesuit and going up there. So you have quite the background in this. So I think it would really help our audience if you could tell us a little bit more about your background and your education and how you got to where you are now.
Sure thing. So it starts when I was in diapers, basically. My mom told me when I was 3, if Mr. Rogers' Neighborhood or the electric company was on, if I was in the room and not doing anything, I might look at the show. But I knew what time, this is at the age of 3, I knew what time and what channel to turn Star Trek on. So I love space ever since I was little. I would go to the library and I would automatically find the space section and just read all the books I could about space exploration.
You were a baby
Right.
Trekkie.
Absolutely. Not really sure why a 3-year-old liked Trek, but I did. So anything space I could get my hands on, that, Space 1999, whatever.
Wow.
When I got to high school, it got to the point where people would come and talk to me about space because they knew that I knew more about it than anyone else at the school. And so I knew that was what I wanted to go to college for. I'd started out thinking I was going to go into the Air Force and use that to get to NASA. And I'd gotten as far as getting accepted to the Air Force Academy. But my parents discovered NASA had just started a scholarship program at Morehouse College. They sent down to Morehouse a packet of all the things I'd done in high school. Morehouse gave me a call and said, will you fill out this application so that you can take this scholarship? It was full tuition plus internships at Johnson Space Center. So that trumped the Air Force Academy.
So
Canceled my,
I got to interject here. How long ago was that? Because that's really incredible that your
Mhm.
parents sought that opportunity out for you and then you pursued it and got it.
My parents were incredible. They were both university professors. My mom taught everything from elementary to undergrad. So they were focused on making sure we succeeded. This was in 1989. I graduated high school class of 89.
Okay.
And really, at the point of graduation, I still thought I was going to the Air Force Academy. So it was in those intervening weeks right after graduation that my parents found out about the NASA scholarship. That program's not still around, but there are other scholarship programs. I'm sure you're informing your viewers about that they
Yeah,
can apply to.
absolutely. As a matter of fact, I'm going to be doing a show on specifically on NASA scholarships. There are a lot of other programs around, but the fact that there was one 34 years ago and you were able to take advantage of that, it makes more of a statement not only that it happened that long ago, but it kind of reinforces the fact that these programs of some sort are available and just need to be sought out, and the kids need to know about them and the parents need to know about them. Your parents being educators, they were already kind of in the loop, so to say, to know to look for it. But
Exactly.
that's just really great. But go ahead.
Sure thing. And throughout my education, I got 4 different degrees. NASA paid for all of them. So it was an amazing journey to get that much education for free.
Wow.
When I got to Morehouse, I didn't know that I wanted to be an engineer. I wasn't exposed to engineering growing up, but I had a home computer, so I taught myself computer programming. I started out in computer science because that was familiar to me and it was comfortable. It was at NASA though, I was finding that I wanted to do more than what I was being challenged to do in my internships. They weren't space related enough for me.
Okay.
And I had the opportunity to interact with some astronauts, Frederick Gregory in particular. I had actually written him when I was in high school, and because he attended the academy, and he wrote me back and gave me some advice. I went and met him again, and as we talked, he actually took me around the astronaut office and spoke to other astronauts. At the time, computer science was not as big as it is now, so they didn't think it was as important as it is, but they said, you really want to major in hard engineering. And he actually took me water skiing too. He said, we can take off work. It was for another astronaut's birthday. He called it official business called surface kinetic investigations. So that was kind of a hilarious opportunity.
Okay, that's really creative.
Mm-hmm. But based on his advice, I came back and changed my major. It was the beginning of my junior year. I switched to general science at Morehouse and aerospace engineering through the dual degree program that Morehouse had with Georgia Tech. So I got my second bachelor's in aerospace engineering. I liked that, but one of the things that I felt was missing, I learned a lot about vehicle systems in my degree, but not much about how the human interacts with the vehicle. So
Okay.
when I went to my master's, I went to North Carolina A&T State University for my master's, got that in industrial engineering with a focus in human factors. That sort of gave me the other piece of the puzzle, how to address the human system.
So
From
you were constantly exploring, okay, how can I take this to another level? How can I take this
right.
further? And that type of
Mhm.
thing. And I'm going to go back on something that I think is really important and I like my viewers to hear that you said, and that is that you reached out to an astronaut. You just reached out to him and that ended up coming back in a very positive way for you, which then gave
Exactly.
you guidance with being introduced to other astronauts and being exposed to other aspects of space exploration of NASA, and giving you the ideas to continue to move forward with your education and that type of thing. All of it comes together. And
Right.
I hats off to you on that, by the way, because I think that's a great example for people to hear about.
It's really important to reach, if you know what you want to do, you've got to reach out to people in that field because they know things about how to get there that you won't find from anywhere else. Because no matter how good your guidance counselor is, unless they worked in that industry, they don't know all the ins and outs, where someone who works there would know and be able to help you
Absolutely.
guide.
Amen to that. And the other part of it is, Robert, is that, and the reason I'm emphasizing it is a lot of young people have a tendency to be shy about it and think
Mhm.
that they're going to, the astronaut or the pilot or whatever is going to bite them. And I'm like, no, most people in this industry, both aviation and the aerospace side of the industry, absolutely love sharing
Exactly.
everything that they know with whoever is interested in it. As a matter of fact,
Mhm.
once you get them started, you usually can't shut them up.
That can be true.
Yeah, yeah. So you furthered your education with the dual degree. Then you
Mhm.
went to North Carolina State, um,
A&T State,
A&T State. Uh, that's a very important part of that.
very important distinction.
Yeah, very important to say. And then what happened after that?
After that, I went to get my PhD. I went to the University of Tennessee Space Institute. It's a teeny tiny school in Tullahoma, Tennessee, which is the middle of nowhere.
Okay,
But what they had was something really special. One of the professors I worked with, Dr. Gary Flandreau, he had been at the Jet Propulsion Lab before his time at UTSI. He was one of the engineers who developed the trajectory that Galileo used to go to the outer planets. So studying under him was really a phenomenal treat, and that was kind of the main draw of that university. I wanted an aerospace degree, but I wanted it to focus specifically on space systems, and Dr. Flandreau was the key for me doing that.
yeah. How does space systems for you transition into space architecture? How did that come about? Because it doesn't sound like space architecture was on your radar at
So
up to that point.
space architecture is somewhat of a new term, even though we've been doing space architecture since the beginning of the space program.
Okay. Yeah.
If you go to space architecture, I think it's spacearchitecture.org, but there's a website of space architects. It defines space architecture as the theory and practice of designing and building inhabited environments in outer space. So that's really everything about building a system that allows people to live away from planet Earth. It involves architecture, it involves engineering, it involves science, it involves space architecture, it involves industrial design. Pretty much every technical field of knowledge comes together in space architecture. So you might have a space architecture degree, or you might have any of those other degrees, but it's how you're taking that knowledge and synthesizing it to get us off of planet Earth.
Sure. It totally makes sense, and it makes sense. It goes back that far since the space program began. Can you give us an idea of what you and your team do in
Mhm.
various areas and within your department
Yeah.
and what your responsibilities are?
So with my focus being habitability, we look at the aspect of how does the astronaut live or work in that space environment. We're not focused on, say, the life support systems or the thermal systems. We're more focused on what's the volume, how is the volume arranged, what sorts of functions need to be present within that volume, and how do you decide which ones need to be close to each other, which ones can actually share the same space, which ones need to be kept apart from each other. And when we're developing these new concepts, we've never lived on Mars. The longest we've been on the moon is 3.5 days. We've only had a few spaceships that have operated in microgravity, so it's still new. So for almost any mission, we're creating a new system. We have to understand how does that work. So after the initial ideation, where we come up with the idea of we want humans to be able to live in this environment, we start developing concepts of what that looks like. That's a mixture of CAD, some sketch work, some calculations. So depending on your focus, you might be sitting at a computer, you might have a pen and paper in hand, you might be using a CAD model, you might be using Excel. Any number of different aspects come together to define what might that spacecraft look like. Once we have ideas, we start to prototype. That can be both virtual using VR, or it can be physical.
Where
Initially,
you
you
actually
start out
make a
low.
model?
Well, we can make scale models, but sometimes we make full scale mock-ups that we can actually go inside and interact with.
Okay.
We'll start
So,
out low fidelity. Oh, go ahead.
no, I was just going to ask you, sorry to interrupt you. I was going to ask
Mhm.
you, though, a lot of this is collaboration with the astronauts that have already been up and experienced traveling in various types of space capsules, et cetera.
It is, although the early stages, we do some development before we bring the astronauts in, since their time's
Okay.
really limited. So we don't engage them until we have a more fleshed out version of what we're looking at.
Okay. Okay. So you were saying you build a mock-up and go ahead.
We start out simple. So whether it's in for VR or for physical, we just kind of roughly define the shapes, make sure we've got things defined the way we want them. Then we'll increase the realism, the fidelity, so to speak. Then we do what's called human in the loop testing. That's where we bring people inside that environment and have them interact with it. It might just be a component test, like if it's a chair for the moon, we might just have them sit down in it. Or if it's an entire spacecraft, we may simulate a mission and have them go through the simulation. For instance, we would go to Arizona in the desert with a pressurized rover, and we would simulate a 3-day, a 7-day, or a 14-day mission where they're using that vehicle to go explore as if they were actually on the moon. So we take that evaluation, whether it's a simple one or a complex one. We ask them all sorts of questions about how the mock-up performed, get their feedback on what was good, what was not good, and we refine the design from there. That gets us eventually to the point where we can write what's called requirements. Those are basically a list of do's and don'ts. So it's everything that has to be true about the spacecraft. For instance, the spacecraft shall have a floor to ceiling height of 2.5 meters. That's an example of a requirement.
Okay.
Those requirements are then put together, and that lets NASA decide what they want the vehicle to be. Then that's when they can tell someone how to build it. Usually what we'll do is we'll either hire a contractor or we'll partner with a international space agency, and they go off and build the actual spacecraft for us.
Got you. So a couple of things then. Well, let's talk about this first of all. So a big factor, and you touched on it a little bit, is the human factor. Can you
Mhm.
expand on that, and can you also talk about um, what somebody's background might be or needs to be, education wise, et cetera, to deal with that aspect of what you guys do?
Sure. So, easy way for you to think about human factors. Let's go back to COVID when we were at the beginning of the lockdown and everyone was staying at home. And let's make it a little bit worse. Let's take you, for instance, Vince, and let's take what we can see of you on the screen. So this part of your office. Let's imagine that one other person joins you in there, and you two can't leave that area for the next month.
Oh God.
So
Okay.
we have to think about what is everything you need to live, be productive, be healthy, be happy in that environment.
Gotcha.
And how do we arrange it? How do we fit a toilet in that volume? How do we fit beds in that volume? How do we fit medical care in that volume? Oh, and not only are we locking you in, we're deleting the rest of the universe. So you can't call 911, you can't call a plumber, you can't call anybody. Or you can call them, but they're on another planet, so they can't help you.
Right.
They can give advice, but you're going to have to do everything. So
Wow.
where are the
Yeah, and so that brings me back to the question of what background do people have that
Mhm.
deal with that aspect
Yeah.
of that?
And that's why it's a team, because no one background can do all of this.
There you go.
Industrial designers are really good for developing what does the shape of that product look like. You have engineers who develop all of the technical specifications. You've got psychologists who look at the psychological, the mental concerns going on. You've even got medical doctors that weigh in. All of that comes together in defining what this space needs to look like. There are even acoustics people, there are toxicology people, there are material science people. So it's a huge universe of people. Of course, architects.
Yes.
It's a huge universe of people that come together.
Yeah. So I had a very interesting discussion with Dr. Pablo de Leon, a professor at UND Space Studies, and of course he deals with the spacesuit and spacesuit design and things like that. But he brought up two things that stuck with me. One was one you just touched on, and that was if you're going to Mars, that's a 6-month trip, and there could be things that you need en route, such as if you have a dental issue or things like that. And he mentioned that. But the one that really stood out to me that I thought was, well, yeah, that sounds pretty complicated, was protecting the astronauts from the radiation, from of being in space and actually moving closer to the sun as you head to Mars. If I'm stating that correctly.
Sort of.
Kind of.
So yeah, let me see how to say this. When people say it's a 6 months trip to Mars, that's an approximation. That's kind of like saying, how long is it to get from New York to LA?
Right.
We haven't said if you're driving or if you're flying or if you're taking a train or even if you're taking a boat. Depending on how you get there, the length of that trip changes.
Okay.
6 months is typical of a chemical propulsion architecture using what's called a conjunction class trajectory.
Okay.
That's what most of the discussion about Mars has been focused on. But there are other systems. So you might have heard in the news talk of something a trip to Mars in as short as 45 days or 3 months. That's an experimental technology that's not available yet, but engineers are working on.
I
You may
had not
also
heard
hear
about that. What kind of propulsion is that?
BASIMR. It stands for variables. I may get this wrong. Variable specific impulse magnetohydrodynamic propulsion. I think that's the right name.
Okay, close enough.
It's basically a system that uses electromagnetic forces to accelerate plasma.
Okay, that makes a little more sense, at least to me. I'm not sure about our viewers and listeners, but
Very
yeah,
futuristic, very advanced.
yeah.
It's actually a former astronaut who championed the concept, Franklin Chang Diaz.
Wow.
There are other people looking at different forms of nuclear propulsion. Some of those are fast, some are slow. So you may also hear people talking about a 1 year trip to Mars.
Right.
That's
Hmm.
that's a low thrust, high efficiency propulsion that doesn't use as much propellant but takes longer to get there.
Does it make a significant difference as to whether that, since we're on the Mars topic, of going to Mars from the moon versus going to Mars from Earth?
Um, that's kind of like saying if you're going to from DC to LA, are you going to the moon from the Air and Space Museum or are you going to the moon from Dulles Airport?
Hmm.
Now, if you know DC, those two are really close to each other.
Right.
So the moon is basically next to Earth. So the distance is about the same.
I was thinking
When
about the
people talk about
gravity.
the gravity is lower on the moon, so if it's something that's leaving the moon versus leaving the surface of the Earth, it takes less energy if it leaves from the moon.
Okay.
But those questions assume a lunar architecture because how did whatever got on the moon get to the moon?
Right.
There are architectures where it makes sense to build up equipment at the moon or in lunar orbit and leave from there to go to Mars. There are the other architectures where you build everything up in Earth orbit and go to Mars. There are arguably the potential for architectures where you go directly from the Earth's surface to Mars, although that requires rockets we haven't built yet. Not even Starship can do that.
Okay. So let me ask you this while we're in the subject of this, Mars and Moon. What are you guys currently working on? Because we're talking about going to the moon in a few years,
Right.
and we're talking about going to Mars in, I don't know, 5 or 10 years, whatever it is. So it's right around the corner,
Mhm.
especially in the terms of what you guys do. So what type of things are you working on, for example, with regard to the moon?
So I've had, over the course of my career, I've had the opportunity to work on all sorts of different lunar vehicles. Most of my time right now is spent on the Lunar Terrain Vehicle. That's an
Okay,
unpressurized rover. You could think of it as the successor to the Apollo Dune buggy. I also do some work on the pressurized rover, so think of more like an SUV with something that's got a cabin so you can take off your spacesuit.
got you.
So
So,
those,
hmm,
oh, good.
go ahead.
Those two give us mobility. When NASA went to the moon in the 60s, The first 3 missions, they didn't have any mobility, so it's just the crew in their spacesuits. They could walk around, but they couldn't go very far because you're limited to as far as you can walk. When they had the lunar roving vehicle, which was their unpressurized rover, they could drive further. What we want to do with the LTV is make it a much more capable vehicle. So it's sort of the next generation LRV. We can drive, we can do a lot more with it. We can reuse it, use it over multiple missions. We can carry things with it. So it's not just the people, but they can carry lots of equipment. We can even transfer equipment from landers to whatever our surface habitat is with
Would
the
it stay on the moon, or would you always, would you, how does that work?
So in our current plan, it stays on the moon.
Okay.
But people could create plans where it doesn't. So that's where it gets into there is the current architecture, but there are an infinite number of possible architectures. It's kind of like you're asking, what does a car do? And it depends on what car you build.
Yeah, man, you put this stuff in plain English. It's just got me going. Okay, yeah, okay, that makes sense. Yeah, right. But it does. And so you're working on those 2 vehicles now. The pressurized vehicle, what did you call it again?
Pressurized rover. It's
Okay.
basically kind of like an SUV. It's got room for 2 astronauts to drive around in it, and it's got a place where they can put on spacesuits to go outside, come back in, place to sleep, place to eat, place to use the
Oh,
bathroom.
it's that big.
It's still kind of tiny,
Okay.
but
Well, when you
the
start
goal is,
talking about taking on and off spacesuits and
Mhm.
things like that.
Let's just say there are still some design challenges.
Okay.
We're working with an international partner for the pressurized rovers, so they're going to have to solve some pretty intricate questions. We've looked at them and developed some approaches, but they're going to have to figure out for themselves which way they want to run.
Do you have to coordinate with, or do you coordinate with the guys that design the spacesuits, and deal with that side of it in terms of making that all work with these rovers that you're in and vehicles that you're working on?
Yeah. Now it's a large distributed team, so any given person on that team may never see my face, hear my name, know anything about me. But we do interact with the suit team. We actually just did a test yesterday. We have a test facility at Johnson Space Center called the Argos. It's a reduced gravity facility.
Mm-hmm.
They basically have a track that runs on top of it with a motor connected to a cable that runs down to a harness. You can put a test subject in a spacesuit, put that spacesuit on the harness. The harness pulls up with the force to reduce the effective gravity on them. So if we want to simulate the lunar gravity, it'll pull up to counter all but 1/6 of their weight. So they're moving around as if they were on the moon. It's not a perfect simulation. It kind of gives you the approach. We were looking at a low fidelity mock-up of our NASA reference version of the lunar terrain vehicle. It's not the version that we're going to send to the moon. We're going to have a company design and build one version. We have an internal version that we use to understand how do people need to interact with a unpressurized vehicle. We
Yeah.
were doing a test to see how do they interact with this, with how can they sit. We looked at 2 different concepts. How can they change a tire? How can they get to tools? Just sort of looking at gross movements around the vehicle.
Yeah.
And we
So
had the suit team with us.
sure. So Robert, as I mentioned, we have a variety of people that watch and listen to the show, but we have a lot of young people that are probably, looking at it and saying, okay, so how do I get into this? So this, a high schooler, maybe middle
Mhm.
schooler, but most likely a high schooler that has an interest in space, the space exploration, doesn't have a clue where to start, not sure if they really want to be an astronaut, but know they want to do something, know they may want to work at NASA or the Jet Propulsion
Yeah.
Laboratory or whatever. What are your recommendations based on your experiences to them about what to think about, what to get involved in, how to get started, what direction to go in terms of their education, et cetera? I know I just threw a lot at you, but
Start immediately. Doesn't matter what age you are, whether you're an undergrad student, a grad student, high school, middle, elementary, not even in school yet. There's no age that's too early or too late. Start reading everything you can. The internet is a huge advantage that I didn't have when I was little. So you can Google to your heart's content about space. And with things like LinkedIn and Facebook, you can actually find people who work in the space industry and speak to them. You definitely need to focus on your schooling. GPA is the number one driver that's going to determine whether you can get here or not.
Okay.
Math and science courses in particular. Also, SAT prep. If you're not already in college, you need to take an SAT preparation course. You can do ACT too, but SAT is more popular. My parents learned with each of us how to prepare us for college better, so they started me with SAT preparation courses. My younger brother got it by accident because they didn't have a babysitter, so he had to start coming anyway. So he started taking SAT prep in sixth grade. By the time he got to 12th grade and took the SAT for the last time, he only missed one question on the entire test.
Wow.
So it is that early preparation that is key. That makes so much of a difference.
Yeah.
You need scholarships and you need internships.
Mm-hmm.
The worst thing to do is to be a senior looking for a job. In the in the science and engineering fields, you don't want to be in that shape. You want to find your job through an internship starting starting somewhere in your freshman or sophomore year.
Wow. Yeah. So I was just that you hit on two key points. The internships. I've seen so many students that once they've gotten into an intern program for whatever it is that they're trying to do, they usually end up with a job right after they graduate. Actually, they're usually offered one before they graduate.
Mm-hmm.
So yeah, that's absolutely key. And then we were talking earlier before we started the show about the importance of scholarships and the availability, more important, of
Mm-hmm.
scholarships, and that a lot of kids unfortunately don't always take advantage of, and they're out there. Every
Right.
kind of scholarship you can think of. Some are small, some are big. You know, some cover everything, and some will help you along the way. So I think that's really key. I wanted to ask you, going back to, what is it about what is now called space architecture that really drew you into doing all of what you do now, that's got the label space architecture?
To me, it's the aspect of creation. Before I even knew there was a field called space architecture, before I even knew there was a field called engineering, I would design and come up with space concepts. My mom tells me, I vaguely remember this. I discovered that if you took a key and scratched it against a wall, it would leave a mark like a pencil, but it couldn't be erased. Now, you would think I would get in trouble for doing that. I was about 8 years old, but she came into my closet and discovered I had drawn out an entire spacecraft control panel. And she was just so amazed that I got away with it.
Of course you
But,
did, because she saw you were doing something creative and educational. So, and her
but
being an
just,
educator, she's like, okay, well, at least you're doing something productive.
yeah,
Yeah.
but just the idea of being able to create things that are new. I look at the moon and I think, what would it be like if someone can look up into the sky and see Earth? And they're at home when they do that.
Yeah. You know, you brought up earlier that there are a lot of people that go into these projects. So the team for building the rover, for building the pressurized vehicle, and all the other architecture that you guys are looking at for space has a lot of people involved. So one question I have for you: how big is a team like your team for the rover, um, and that type of thing?
So it's all teams. It's literally even teams of teams. I couldn't exactly tell you how big the rover is because there are different teams that make up the rover team, and you don't necessarily ever see everybody all in the same room.
Right. So I was going to
I,
say some of them are from different parts of the U.S., from companies, et cetera, and so forth. Right.
exactly. Right. Mhm.
Yeah. Yeah.
So the team that I lead, the Center for Design and Space Architecture, we're a small team of about 10 people,
Okay.
and we've got maybe about half the team working the lunar terrain vehicle, the other half working the pressurized rover and other mobility studies.
Yeah.
We interact with other engineering teams. Sometimes some of those teams are focused on design and some of those teams are focused on testing. But that broader team interacts with other teams that deal with things like what's called acquisition, which is basically how do we take an idea and put it out to a contract for a company to bid on.
Sure. How do young people, if they're interested, like they're in high school, is there an opportunity for them to come and tour? Like if they live in the Houston area or they're visiting Houston because of family or friends or whatever, to come and tour what you guys do or some aspect related to it there at Johnson Space Center?
So that does happen, and it happens in different ways. Every NASA center has some kind of visitor center. The one for Johnson Space Center is called Space Center Houston. They have tram tours where you can actually get on a tram and they'll drive you around. You get to go inside mission control. You can go into our mock-up facility and you can see several of our mock-ups, including that Argos rig that I was telling you about. If they'd been there at the right time, they could have seen our test yesterday, but there will be more.
Yeah, I
But
would think
that's
that's very important to come and see for important and inspiring
exactly.
to come and see in person what you guys do and what's all entailed with it because NASA is quite the operation in terms of all of the things that NASA's doing at the various space centers and research centers, et cetera, and that type of thing. So
I
I
forgot
think,
to
go ahead.
I forgot to mention one other thing. It's not a tour, but I strongly recommend anyone who knows they're interested in space to go to space camp. I used to always want to go. My parents always said they couldn't afford it, but my senior year in high school, I found out about a space camp scholarship. And I bet that scholarship is still around. You
Yeah.
basically write an essay, and if you win, they'll pay for your trip. So you get to go to space camp. I had a fun story with mine because it was the essay contest. It was a question. You're the director of NASA with limited funds. Sound familiar? They
Right.
said, will you choose a space station, a moon base, or a Mars mission, and why? And when they said creativity is part of the answer, I knew I couldn't choose any of those three options. To me, it wouldn't be creative enough, no matter what I did with it.
Hmm.
So I came up with another option. It was a spacecraft that I called the Mobile Space Base. It was a modular vehicle that could orbit the Earth like a space station. You could reconfigure it into an interplanetary spaceship, refuel it in orbit, fly it to either the moon or Mars, separate it into descent elements that each had their own landers, landed on that surface, and you now have a moon base or a Mars base. So my answer was do all three.
And boom, you got in space camp.
I got in space camp.
Thanks for talking about that. Not only sharing the story, but the importance of about the essay. Most scholarship programs or scholarships that are available require an essay as part of the application process, and that seems to intimidate a lot of people that are nervous about it. But you brought up an important point. Just be you and say what means the most to you in
Exactly.
terms of your passion for your interest in space exploration, and it'll take care of itself in most instances.
It really will. And don't be afraid of writing. When you have a writing assignment, break it down into pieces. If you can keep breaking it down until each piece is only a sentence long. And then it becomes easy to write because it's easy to write a sentence. It's hard to write a 3-page paper. But if you
Yeah. So as we wrap things up, that brings us kind of a nice transition to this, and that is specifically getting a degree in space architecture is not a norm.
Mhm.
I found out very quickly that there are only a few schools in the world that actually have that as a major
Mhm.
and as a graduate program. What are your thoughts about that, and what are your recommendations for somebody that is going to want to try to figure out what aspect of space architecture they're actually interested in, especially when you do space architecture, uh, habitability, and human factors?
Mhm. Follow your passion. That's the most important thing. You know you want to end up in space, but there are literally hundreds of different degrees you can use to get there. Find what excites you the most, and that's what you need to zero in on because you're going to be the best at the things that you're most excited about. If it's a area you don't like, then that project or assignment you have in school, it's going to be boring, it's going to be hard. You're not going to want to do it, and you're not going to do your best. Versus if it's something you're excited about, you won't mind doing the homework. Even the parts that are tedious, you won't mind as much, but you'll even find yourself wanting to do more than the assignment asked for. That's when you know you're in the right field.
Dr. Robert Howard, this has been very enlightening, and I love the way you give the what am I trying to say? The way you do the comparison or the analogy that makes a whole lot of sense on everyday things that we deal with, and then applying that to a very specialized field. So I really appreciate you taking the time to be here and to talk about this. And I hope that it has inspired some of our audience to really take a look and give it some consideration and go after it.
My pleasure, Vince, and good luck to everybody.
Yeah, thank you very much. Hey, that does it for part one. And in part two, I will talk with Clare Luckey, the young lady I was telling you about that I call the newbie. And she's at the Johnson Space Center's Mission Analysis and Integrated Assessments and is part of the Mars architecture team. I highly recommend that anyone in middle, high school, college, and even postgraduate watch and listen to this interview. Claire is representative of many who figured out things along the way. It was a great conversation. Thanks again for joining us and hopefully enjoying these enlightening discussions with very smart and very talented aerospace professionals. As you know, my goal with every show is to inspire any and everyone who has any kind of interest in literally any aspect of aviation and aerospace. And I encourage you to consider every option and every possibility. Thanks for watching this edition of All Things Aviation and Aerospace, a media presentation of Private Air Media. If you like what you're seeing and hearing, please subscribe. Until next time, take care, stay safe, blue skies, and have a good one.